the presentation packaging tool with Daniel Lovasko. He is here. Yesterday, the plan of this day has been changed a little bit. We have this presentation half an hour until 10:30, and after that we will have a break of half an hour, and at 11 o'clock Hannes Reinecke tells about megasers and steroids QEMU device pass-through with VFIO. The new plan is outside too.
Okay, hi. My name is Daniel, and I will talk here about the packaging tools. So you are right here for this presentation. So first question may be, what is it? What are the packaging tools? So it's a set of scripts we wrote here in Prague that make your packaging tasks more quick, and they make it easier for you to do all these things that have something to do with packaging work or workflow. So I will talk first about the motivation, why I developed these tools, and then why I use them, my motivation to use them, and that may be also your motivation to look these tools up and maybe give them a try. Then I will talk about how to use them, what are them, and in the third part I will talk about how to use these tools not by human but by another script to automate some things that don't need some maintainer to work, and then there will be part when you can ask me and I will hopefully answer you. So the first part, the motivation. So first there's this basic one that I wanted to remove repetitive and boring tasks that come along when you're working with the packages. This is really the basic motivation, and it's really maybe the most important one. Secondly, there is this establishing a standard. You know what? When I write some scripts for package A, and my colleague writes a script for package B, and we share each other's scripts, and you know I have no idea what that is. You know, he uses his own functions, his own stuff, and I have like no idea. And if we both used the same tools, for example, mine, we can easily understand that. You know, so standard is really important. The third thing is to deal with flaws in some tools lying underneath this stuff. For example, the command line interface to the build service, or the RPM spec files. They are not that great, and I think my tools can help with that. And the last one is to put the package in the center of the work you do. Not other things, just the package. You know, you work with packages, and you want to do your stuff with a package. So it's really important. It's like a buzzword here. So the maintenance workflow. So now we can describe what is like, to abstract it somehow on one level more. So first you want to branch your package or check it out from the build service. And when you're maintaining something for the SLAS or for OpenSUSE, it's again, you need to work package centric. So my tools does that for both. Second one, you want to unpack the sources, and for example, when you're working with some patch stack there, quilt is really important for you. So you want to build some quilt series. Third third thing is to, then is the part which I can't help you with. It's just updating the package or fixing some bug. And there is, again, no help for that. So after that, you want to make some changes to your spec file. You want to add the patches there. You want to change version. You want to change some file name and all this stuff. And my tools can help with that. And the last one is you want to submit your changes back to the server, which can be sometimes really annoying when, for example, you are doing something in your home branch, then you have to submit it to the devel project, then build it there, then to the factory. So there is a way to make these things better, to how to make them. And so the important question here is, how can these tools help you or any package maintainer out there to do their job? So here's the answer. First thing we made is a getpac command, which is some kind of reincarnation of the old getpac, which you may remember. So what it does, that it downloads the package in all maintained products. So that means it downloads it for all the OpenSUSE and all the slashes that contain this package. And the second thing, it creates nice and clean directory structure, which is the OSC is not capable of, in my opinion. And there is ability to remotely delete some files. So when I know I'm updating just some tarball, and the tarball is really huge, and I have no time for downloading it for every maintained project. I might also want to only branch the package on the server, then delete the files before they download, because I know immediately after I will download them, I will remove them. So it's really pointless to download them and just do nothing with them. So this is to prevent this wasting of network. And then I made some also bash completion, which I will talk about later. So this is how it looks. You write, there is some kind of master command behind all this, like when you use git or this kind of stuff. So it's called a PCK, so it's just like for package, or because PKG was taken. So you write a getpac and the package name. There are some options. For example, I can write SUSE and then some regular expression which says that I want only these versions of the package in these SUSE maintained products. So for example, when I write there like 1 and all this wildcard stuff in left and right, I will end up with only slash like 10 and 11. The same goes with the OpenSUSE. Then there is a special option for factory, and the branch there means that when I'm a maintainer of it in the devel project, I might want to only check out the package, not to branch it also. But there were some requests that sometimes I need to branch it also, not only check it out. So there is like some force option to branch it, and then the delete pattern. Again, some regular expression to say which files I'm going to download, which I'm not going to download. So here is the directory structure it creates. So let's imagine I wrote the getpac sed, the line editor, and what it creates is like the set directory, and then there are these nicely named directories under it in the directory tree that are simply more useful. And this is the example of package-centric approach in this thing. So when I'm working with some package, I want them all in one directory, which for example, when I do mbranch, it gives me the 11.4 version in my 11.4 directory with all those packages. And when I'm working on one package, mostly, well, I'm not working on like 5 of them in one time. So the thing is, I'm working on one package, and I want all my versions to be in the same directory, so I can easily do some operations on it, like for example, find, which is really easier to do when I have them in one tree. So, and this bash completion that I talked about, when I write the PCK getpac, and then I, for example, forgot that I want to not to waste time, it completes the package names from the OSC my package list, which are the packages that you are maintainer of. So, next thing, this is the ability to delete those files. So, for example, when I want to delete all the zipped tarballs, I just write regular expression like this, and they before the final checkout they are deleted. So I can replace them with like some of my own or the new version. Okay, the second thing is you want to unpack your sources, and quilt setup is the thing you've probably used for that, and it is somehow slow because of the. Sometimes you don't want that much security when you're working with your own package. You know, you trust your own package. You or some of your colleagues, then make changes to this package, and there is like no reason not to trust it. And Quilt does the thing that it unpacks the tarball 2 times, and when the tarball is really big, huge, and you have to do it twice, it really slows you down. And there is another flaw with the quilt setup, that when in your patch list one of them fails, your quilt series is not created. You know, you get the unpacked sources, but no patches applied. And what we've done here, that we wrote some replacement for the quilt setup, and we called it fastre, which is again some wordplay for the command used before, the re, and the fast word is to really say that it's really faster than the quilt, because it does the unpacking just once, and there are many packages that this is really crucial for. So the another really important thing is that even if one of your patches, let's imagine we have like 20 patches in our series, and we need and the 10th of them just he won't apply. You know, what our thing does, what our script does, that it applies 9 of the patches to the series, and then waits for you to apply the 10th, you know, to fix those rejects there. So this is really important thing that is not in Quilt. Third thing is to detect when your package contains the directory patches or the file series. For example, package Amanda has that, and Quilt has problem with that. He won't be able to unpack that. And there is the thing I talk about, that every table gets expanded just to once, which improves the performance. Then making changes to the spec file. So first thing is a really common thing you do when you do the packaging workflow. You add patches there. You know, that means you add the tag with the name of the patch, and then to the prep section of the file you add the macro patch. And what does this command? You just write pck spec, which is the command that does all this, and you write add patch, and then the patch name, and the magic is done. It will be inserted into the tag and also to the prep section. Then there is this easy way that you can write and read text and or the whole prep or every section you just write there. The thing is that is really amazing is to read these things across all maintained versions. So when I for example ask what is the version of Bash in every maintained product, so I will get list like this, which content like in the factory there's version 4.2. So when I'm maintaining something and I know that there is this problem with this, I need to fix this in versions 3 and higher, I just look at this and I know that there is no need for me to fix it for, or you know what I mean, that just you can easily see what are the versions and then you can focus on the products that are in some kind wrong or broken. And the thing I haven't spoken about is the merging of conflicting patches. So let's imagine I have two patches A and B and both end with a patch number 8, and that is a problem. And there is a solution for this problem. The merge thing here is that the first file you put there gets the priority, and the second one is moved to the patch 9. And also it is renamed in the prep section. So the submitting bed, as I told, there is this command, we call it PCK bubble, some kind of bubbling up in a tree. So when you develop something for the factory, as I talked earlier, you have your branch, then you have to submit it to the develop project, and you have to wait for successful build. And after that, you have to submit it to the factory, and then wait for the build there. And this can be automated, so let's do that with this command. So this is all for the tools that you can use. There are some more special ones that fix some problems, but they're not just important. But when you look at our page that I will show later, you can find those tools also there. And the last thing I will talk about here is the update creation, which uses these tools. Like I described the packaging workflow, and when except for the bug fixing part, we have it all here. And when you're updating some binary package or some package that only you just update the tarball again, there is no need for package maintainer to lose his time with this repetitive and somehow boring thing. So we can use these tools for just getpacking all the maintained versions. We then do some MD5 hash of the new tarball, of the tarball we downloaded, of the tarball we branched with the getpac command, and then we can see, is it new? Yes, we can put it there. We make some changes automatically to the spec file, and we bubble it up to the factory, or we just submit requested to the appropriate repository. So that's all. So if you want to help me or help us with these tools, there is this Guitarist project in Guitarist.org, open source spec tools, and also we've submitted this. There is also an package for this in utilities project, which will be soon, I hope, accepted for the factory. So thank you very much for listening. Now is the time for your questions, and then hopefully I can answer them. Yes, the R delete. Yes, it will delete it from it, and but it's just your branch, you know. So it's okay, and then you can replace it with a new one. Okay, so probably there are no more questions. So thank you for attention.